You're checking our channel here. So this just isn't going to be a repair video. I started making a video on this one, but it took me forever to get it figured out, and it was going to be a really long video, probably an hour plus long, trying to figure this thing out because it has just wore out, and you know they don't make any new parts for this unit, so this is a you have to rebuild and or retrofit. But with this being a solid state unit, not low impedance, you know, anything built in the last 40 years that's low impedance part-wise will not work in this unit. You'd have to basically gut the thing in order to make it work. But this is units from the mid-80s, somewhere in that range. It's a Bulldozer brand, model 4444A. So I'll just show you the inside of it, what we did to the thing. Basically had to rebuild the board and stuff like that. The transformer was ohming out okay. There's this piece here, this little... People, oh, it's a capacitor, and it's not a capacitor. Well, it kind of is, but it's not a capacitor in the sense. It's an MOV, basically. It's a metal oxide varistor. It's a surge suppressor for lighting on the fence and ground side. A lot of brands did this back in the day, and a lot of brands continue doing it today on some stuff as well. Some of them have it built on a board. Some have it built into a little thing that plugs into the front of the thing. Some have them built into other circuit boards on both the AC and the output. But this unit was built back in the mid-80s. There's the transformer here. This thing's still good. There's the main board. There I was having a hard time with the soldering on there, so we just hardwired it and soldered this on the back. So this is way oversized for this application. But because I didn't have the factory size one that was originally on there, I didn't have any of that stuff. I was like, well, this will work. So I put that on there. That SCR there. We had to change out some resistors. There was one resistor here and one there. I didn't have the exact size, so we put two in series right there and right there that were pretty darn close. We put in new capacitors, both one right there and this one here. It was soldered across there, but I didn't have an axial capacitor where the leads come out both the ends. So I had this version, so I just soldered it across the old leads that were coming out from the old capacitor. And I put a new fuse in it as well. This bulb over here is burnt out, but it's not a necessity, so I didn't even bother changing it. And we did put a new knob assembly on here. We kept the original porcelain that they had on here, but if you would tighten it up on the nut there, it wouldn't tighten up right, so we had to put a different bolt in there. And then I had to put that spider washer behind it. The original had that on there too. But it seems like when you tighten it up, the whole thing would spin, and you could start to hear this thing this thing was in a crack. It didn't make the crack, and sometimes I was like, if I tighten up too much more on the original one, because it still would want to turn. So we put a new bolt, a new nut and washer assembly, and I found this nut off of a Parmac unit. It fit on there just perfect, so we put that on there for the fence side. But we'll plug it in here and you know, show you that it's working and stuff like that. Now these old solid state units, I mean, they can't handle like real big areas, and they can't run, you know, real long fence and everything. We can run some fence, but they basically, the further out you go, of course, there's more resistance in the wire. The further out you go, there's more resistance that the energy has to travel through, and these things will kind of slowly get weaker and weaker and weaker. Voltage drop as it goes out, the further out it goes, and they don't have the low impedance transformer board design to where the load of the fence and the grass and line doesn't dog it down. These get dogged down a lot quicker than a low impedance one will, up to a certain point. So I say a 2 to 5 joule unit will outperform this one, and you know, every day of the week. But half to 1 joule will probably be on par. We'll do my meter that does the load testing and my joule testing. The battery's dead in the thing, and I cannot find my battery charger for it. It's somewhere. I don't know. I dropped it, or I don't happen to it. But anyways, I can't find it. But we'll put our meter across there. We use the old analog one, and light down here still flashes on it. There's a little flashing light here at the front. That's your fence okay light. tell you that your fence is doing good. You're getting about 7,500 volts out of it. And then we'll see a little light flashing inside there. It's kind of hard to see. Turn the overhead light off. And you can see it flashing. Camera's not picking it up every pulse for whatever reason, but it is flashing every single time. Probably a frame rate issue. Just turn it off one more time. Let's take the knob off here, and we'll do a little spark jump. Now you saw the state ones; they would throw a pretty big, long spark. The thickness of the spark wouldn't be real big. If you look at a 5 or 10 joule unit, the spark won't be as long as this one, but it'd be a lot thicker. It'd be a lot wider. So I'm going to go to the ground side, which is down here. I'm going to zoom in a little bit. I'm going to touch the ground side. I'm going to get close to the fence side over here. It throws about a 1/4 inch spark out of the thing. About like that. Somewhere in that range. It's about how long the spark is. But if you put a load on it, it just about kills the thing. Which I can technically put a load on there with that meter. I just don't have it won't turn on for the display part of things. So we'll at least do that part of it. Let's put a now standard load for most units today, at least low impedance one last 30-40 years. Standard load that they measure things off of for voltage wise is a 500 ohm load, and that's what we've got it set to right now. We got plugged into 500 there, and I don't know if this is going to matter over here, but I went ahead and put the switch over here to 500. And so when I turn this on, we'll stick this load across it. I'm going to take these leads, I'm just going to stick it across there, and you'll see how this number drops. So right now it's peaking out about 7 to 8, so right there. So let's do a standard load. Let's go across the two terminals. See, standard load just about kills the thing. 0.5 kilovolt. So see, these things don't have the capacity, the high energy, capacitive discharge, low impedance stuff in there to handle a standard load today. So we'll move it up to 1,000 ohms, which is further away from 0 ohms, which is a dead short across fence and ground. So this it'll still drop it down, but maybe not as far. Maybe we'll get in that 2 to 3 range. A little higher, about 1.5 versus half. So we gained about the same, or gained double the amount of voltage out of it. 1,500 volts versus 500 volts with the standard load. So these, just as a example, a Gallagher S17 solar. The only reason I'm picking that unit because I have that one memorized. That is a 0.17 stored joule per like 0.12 output, something like that. So, and peak voltage on those was between 8,000 and 9,000 volts. With a standard 500 ohm load, those would read about 2.5 kV with the standard load. So you can see a 500 ohm load drop this down to 500 volts. So, they just don't have that low impedance where it has an internal resistance fighting against itself, basically. So these things put out all the power you'd ever want or never enough. So that's where you kind of have a sweet spot in there where you have a little load on it, but as you further down the fence line you go, the more resistance that the charger shock energy has to fight through as it goes down the line farther. And if you use that poly rope, poly wire, poly tape stuff, that has a lot more resistance in it, and so that will fall on this type of unit will fall on its face real quick the further out it goes on stuff like that. But on like regular smooth wire, steel, galvanized aluminum fence wire, that has a lot less resistance, so you can run further with that stuff than you can a poly rope or poly tape turbo wire type of stuff that's out there. And everything, but yeah, these are good little units for what they can do. I mean, they're not gonna win any of the races when it comes to like performance on 100 acres, but on smaller acreage or smaller areas or a garden or something like that, this would be real good for that type of stuff, easily. But that's about basically it on the thing. It's a good little old school unit, working again. Kept another one from being thrown away in the trash. So thanks for watching our channel and see another one of our videos here. And like I said, this one took me a little over an hour to figure out and go through it. It was just a little trial and error, go back through it one more time, just to get the thing going. But luckily we saved it from going in the trash, and hopefully this thing goes another number of years. I don't know if this has ever been worked on before. There's no date on anything inside here. The serial number doesn't reference any kind of date format in their stuff. I did have one of these come in for repair one time, a year or two ago, and there was a sticker on the inside somewhere in the back, in the top case, somewhere. This one doesn't have anything in there, but it said like 1983 or 1988 or 85. It was the mid 80s either way. So it's a 40, give or take year old design, unit. But these are good units for what they were designed to do. Well, thanks for checking our channel, and subscribe if you haven't already. And until next time, we'll see you guys later on.